In this session, we will do the exercise related to preparing a salt, like how we can prepare different types of soluble and insoluble salts. The first question, we have potassium iodide and lead nitrate are both soluble. Like they are soluble, they can dissolve, but lead iodide is insoluble. Describe how a pure dry sample of lead iodide could be made from a solid potassium iodide and solid lead nitrate. So whenever we want to prepare, so as you can see in the question they give, we want to prepare insoluble salt. How we can prepare insoluble salt? The technique is known as ionic precipitation. So what we do to prepare insoluble salt, so we mix the soluble salt solutions, like one soluble salt solution mixed with another soluble salt solution. As a result, it will form a precipitate. So what we have to do, first we have to make a solution. We have solid potassium iodide, but potassium iodide, they mentioned it can dissolve in water. We have solid lead nitrate. They are both soluble. They both can dissolve in water. And we want to prepare lead iodide from this. So if we have potassium iodide and we have lead nitrate, so when we mix them together, as a result, what it will form lead iodide. But these two are the solid. First thing what we have to do, we have to make the solution. So we will add water, like take a test tube, add solid potassium iodide, and then we will fill it with the distilled water. So water is added, and as a result, what it will make a solution. Same thing, we have lead nitrate, which is a solid lead nitrate. We add this to a test tube, and to the test tube we'll add water. As a result, when we add water, it will also dissolve because both are soluble. So now we have these two solutions. When we mix them together, the lead will take position of potassium, so it will form lead iodide or lead to iodide plus potassium nitrate. So this is the lead iodide is an insoluble salt, so that will be solid, and potassium nitrate will be soluble, so it will be aqueous. So when this reaction happen or occur, there will be aqueous potassium nitrate. The solution will be there for potassium nitrate, and in this solution, what we'll observe? We'll observe lead to iodide as well. Lead to iodide is yellow in color, so we'll observe potassium, lead iodide there, and potassium nitrate as a solution. But the equation must be balanced. So for this, like to identify what, because if the ratio between the two reagents is 1:1, then we'll take equal volume of the two salt solution. But if the ratio is 1:2, then if one we take, like example, 5 cm cube, the other one should be twice, so it should be 10. If one we take 10 cm cube, the other one should be 20. So if we balance this equation, 3 multiplied by 2 oxygen here on the left hand side. So we must have 2 oxygen on the right hand side. So we put 2 oxygen is balance. Then to balance other element, potassium is there too. So if we put 2 here, potassium is also balanced. So according to balance equation, the ratio between them is 2:1. So when we mix the volume, say if we mix 5 cm cube of potassium nitrate, then we should mix 10 cm cube of potassium iodide. As the ratio, according to equation, when they react with each other, is 2:1. So the volume ratio should also be 2:1. So the steps here, because the main thing is uh, identifying the equation as well as mentioning the steps for this. So first we'll dissolve the solid in water and make a solution. So we will add water to potassium iodide and lead nitrate in two separate test tubes to make aqueous solution. That is the first point. Then after making an aqueous, as we know, like the ratio according to equation, if we should have twice the volume of potassium iodide compared to lead to nitrate. So we will mix 10 cm cube you can put the equation in the answer here, but that is not having mark because they did not ask to write equation. Equation is just a reference for you to identify that if the ratio was 1:1, it means that you will use equal volume of the two solution. If the ratio is 2:1, then one volume should be twice compared to the other. So because potassium iodide, we need twice compared to lead nitrate. So we mix 10 cm cube of potassium iodide with 5 cm cube of lead nitrate. Why we did not take the equal amounts? Because as you can see the equation, the balance equation between the reaction between potassium iodide and lead nitrate, the ratio is 2:1. That's why the volume ratio should also be 2:1. So it is important thing that you first identify the equation correctly. Then we'll mix the two, mix 10 cm cube. After mixing them, remove the solid or the precipitate of lead iodide by filtration, because when we mix them together, as a result the solid will form. So we remove that by filtration, and then we will wash the precipitate with distilled water, and then we will dry with the tissue paper, or you can mention a filter paper. So these are the points you have to mention, that we dissolved the two salts to make a solution and then we mix them together, because whenever you want to prepare the insoluble salt, you have to mix the two salt solution, not the solids. Then why specifically I mentioned 10 cm cube with 5 cm cube? Why not equal amount? Because the ratio between them, ratio between potassium iodide and lead nitrate is 2:1 when we write a balance equation. That's why it is 10:5. Like the amount of potassium iodide should be twice as compared to lead nitrate, as we are using the same concentration of the two solutions. Then remove the precipitate of lead iodide by filtration. Then we'll always wash the precipitate with the distilled water, and then we'll dry this by using a tissue paper. This is how we can prepare the insoluble salt. So what are the technique? What is the technique for prepare insoluble salt? We have two salt solutions. We mix them together. When we mix them together, a solid will form. So in this one, in this question, we have two salt solutions. We have, first we were having a solid. We were having a potassium iodide and we have lead nitrate. So first we dissolve the solid to make the solution. After making a solution, we mix them together. When we mix them together, as a result, it will form lead iodide and potassium nitrate. So this lead iodide is an insoluble solid, or it will be a precipitate which we can remove by filtration. So making a salt solution, mixing them together, then filter and then wash. That's how we obtain the solid or a salt, insoluble salt from the mixture. The next one, write ionic equation for the formation of a lead to iodide. Yesterday I mentioned if you want to write an ionic equation, what which solid we want to prepare? We want to prepare lead iodide. So PbI2 we want to prepare. So in the reactant side, we should have ions. So what are the ions present in lead to iodide? So lead valency, that is +2, and iodide ion group 7, so -1, and there are two, so we put 2 before that. For ions, we cannot put a subscript here, like if you write iodide ion as 2, that is wrong. For a molecule, you can write, but not for a molecular, or for ion, you cannot write like this. So lead is +2, iodine is -1, and there are two. So Pb +2 plus 2i -1 gives PbI2. They did not ask for the state symbol, but always remember the ions will be aqueous and the precipitate will always be solid. So they did not ask, like state symbols are not required, but uh, so it's not having marks, but some equations they ask for state symbol. So always remember for ions, it is always aqueous, and for the precipitate, it will always be solid. So there might change the question here, like example, write an ionic equation for formation of, say, silver chloride. So if I need a silver chloride, so silver chloride is a precipitate or AgCl. Then we identify the ions. So silver is +1 and chlorine is group 7, so -1. And this will be aqueous and solid. In question 2, magnesium sulfate and lead 2 sulfate are examples of the salt. A student prepared the magnesium sulfate crystals starting with magnesium carbonate. So here, student is reacting a metal carbonate. When a metal carbonate is added to any acid, when a metal carbonate is reacting with an acid, what will be the result? It will give salt, water, and carbon dioxide. So as you can see here, an acid mixed with metal carbonate, it will give salt, water, and carbon dioxide. So there will be fizz, bubbles, effervescence. And we always, whenever we are preparing a salt, we always use excess of the metal or metal oxide or metal carbonate, like more than enough. So how we know we use excess, like more than enough metal carbonate? Because if all the acid is used up, there will be no more bubbles formed and no more solid dissolved. So we are preparing magnesium sulfate by reaction of magnesium carbonate with sulfuric acid, because when magnesium carbonate, which is MgCO3, reacted with sulfuric acid, yeah, that's right, the magnesium carbonate, when it is in excess, so there will be no more bubble formation or a solid does not dissolve. So it will produce magnesium sulfate, MgSO4, plus water, H2O, plus carbon dioxide, CO2. And the equation is already balanced. Yeah, it's already balanced, so we don't have to balance this. Now, what student did? A student added excess of a magnesium carbonate to a small volume of a dilute sulfuric acid until no more magnesium carbonate would react. So first, student was having a small quantity of an acid. So there was a small quantity of an acid, and student add magnesium carbonate. When he add magnesium carbonate, he added more than enough magnesium carbonate until all of the acid is used up. So it will become a salt solution and unreacted magnesium carbonate will be there. The student filter the mixture. What is the reason why student filter the mixture? To remove the unreacted. The student remove the unreacted magnesium carbonate, like this extra magnesium carbonate student remove by filtration. One student removed this by filtration, so he's left with a salt solution, which is magnesium sulfate, and he carried out, these are the point of crystallization. Like he heated the filtrate to obtain from step 2 until it was saturated. The student allowed the hot filtrate to cool at room temperature, and then the crystals are formed, and then he removed the crystals. How did the student know when the reaction has finished in step 1? Like how student know that all of the all of the acid is used up? So bubbles stop forming or a solid stop disintegrating or does not dissolve. This is right. So there will be no more bubble formation or the solid stop dissolving or breakdown or disintegration or reacting. Then name the residue in step 2. In step 2, when student filter, what is left on the filter paper is called residue, and what, because when he add excess of magnesium carbonate, this will become magnesium sulfate. The salt solution will be magnesium sulfate, and unreacted magnesium carbonate will be left on the filter paper. So what will be the residue? The residue will be magnesium carbonate, not magnesium sulfate, because magnesium sulfate is a solution. So magnesium sulfate is a soluble, so it cannot be magnesium sulfate, it should be magnesium carbonate. So the residue which is there, that is magnesium carbonate. Then a saturated solution forms step 3. What is a saturated solution? Like you have to define a saturated solution, a solution which cannot dissolve any more solute at a particular temperature. 1 mark is for mentioning a particular temperature. So solution which cannot dissolve any more solute at specific temperature, because the solubility changes with the temperature. So we call that as a saturated solution at a specific temperature. It has a maximum amount, like it cannot dissolve any other amount in it. Explain why magnesium sulfate crystals are formed during step 4. So step 4, what we did, we cool down. So when we cool down the solution, the solubility of the solution decreases. Like at high temperature, solution can dissolve more salt. At low temperature, the amount of salt dissolved in the solution will decrease. So the solubility of the solution decreases with the temperature. That is the reason the crystals start to form. So when we cool down the solution, the crystals will form. Before that, there will be no crystallization. Like because in a hot solution, it has higher solubility, it can dissolve more salt, so crystals will not appear. But when it cooled down, the solubility decreased, so the amount of the salt cannot, like it cannot dissolve too much salt in it. As a result, the crystals will appear. So why we cool down the solution? We cool down the solution so the crystals start to form. Like basically what happened in this reaction, initially we have a container which was filled with sulfuric acid. So this was H2SO4. Because we are preparing a magnesium sulfate, so this is sulfuric acid. What we did, we add magnesium carbonate MgCO3. When we add this magnesium carbonate, the product, whenever magnesium carbonate is reacting with sulfuric acid, when acid react with the carbonate, it will give salt. So it will give sulfate salt, magnesium sulfate plus carbon dioxide plus water. These are the products formed. Now, we add more than enough magnesium carbonate, like too much magnesium carbonate is added. Once too much magnesium carbonate is added, so means this salt, this acid is no more there. The acid is used up. And this solution now turn into magnesium sulfate solution. Before it was aqueous sulfuric acid, but because too much salt is added, too much magnesium carbonate is added, so all the acid is used up. All the acid is used up. When all of the acid used up, what will happen? These are the unreacted magnesium carbonate. So this is the unreacted magnesium carbonate or magnesium carbonate which is left without reaction. How we can remove this unreacted magnesium carbonate? How we remove this unreacted magnesium carbonate? For that purpose, we use filtration. So this is a filter funnel. And we have a beaker here. When we use filtration, the unreacted magnesium carbonate crystals, magnesium carbonate, the unreacted will remain as a residue that is not able to pass through the filter paper. And the solution, the magnesium sulfate solution which was formed, that will pass through the filter paper, and that is a filtrate. So this will be magnesium sulfate, which is a filtrate, and the unreacted magnesium carbonate is actually the residue. So first they ask what is the residue here. First they ask what is the residue. So the residue is magnesium carbonate. And now we have magnesium sulfate. Now the magnesium sulfate is dissolved in water. So first what we did, we use a process of crystallization. So what are the steps of crystallization? First we heat and concentrate the solution. What does it mean? Like initially we were having a large volume of magnesium sulfate solution, but when we heat and concentrate the solution, we reduce the amount of magnesium sulfate, so water basically. But the solution is still hot, so the magnesium sulfate still dissolve in it. Like not too much magnesium sulfate will crystallize. As we heat and concentrate the solution, the crystals will not appear. Why? Because it's still a hot solution. A hot solution can dissolve more salt. But when, with the passage of the time, when we cool down the solution, what will happen? The crystals start to form. So they ask why the crystals start to form, because the solubility of a solution decreases with temperature. At low temperature, it cannot dissolve too much salt. That's why the salt start to appear or crystallize. In question 3, again, as you can see, we have lead 2 sulfate is insoluble. So you can see the mention in the question that which salt you are preparing. So we are preparing an insoluble salt. So how insoluble salts are prepared? Insoluble salts are prepared by mixing the two salt solution. Describe how to prepare a pure dry lead 2 sulfate by reacting lead nitrate or lead 2 nitrate with sodium sulfate. First thing, better is, yeah, that's right. When we mix the two soluble salt solutions, it will produce an insoluble salt. So include a series of key steps in your first lead 2 nitrate. The formula for lead 2 nitrate PbNO3 in a bracket 2. Sodium sulfate, sodium is group 1 plus 1 and sulfate is SO4 with a valency minus 2. So sodium sulfate is Na2SO4. When we mix them together, it will form lead sulfate. So lead is plus 2 and sulfate is minus 2. So it will be PbSO4 and NaNO3. Because sodium is plus 1 and NO3 is minus 1. That's why it is NaNO3. Then we balance the equation. We start with oxygen. 3 multiplied by 2, 6 plus 4, 10. So we want to make 4 is already there. So if I put 2, the oxygen is balanced. And then rest all of them are balanced now. Like sodium is 2, lead, it's balanced, all balanced. So as you can see now, the balance equation is 1:1. The balance equation, according to balance equation, the ratio is 1:1. So we should mix equal volume of the two solution rather than like 1:2. And we already have the solution. Here we don't need to dissolve because they mentioned we already have the solution of these two. Before that, why we make a solution in question 1? Why we make a solution? Because in the question they mentioned we were having solid potassium iodide and solid lead nitrate. First, we want to make a solution if it was solid, but now we already have a solution, so we don't have to add water. So we will use the ionic precipitation. So the same way how it is done, like you can see, we'll mix the two salt solutions. We have two salt solution. We mix them together, a solid will form, then we'll filter, dry, and wash and then dry. These are the steps we will take. So the key steps, we will take equal volume of lead nitrate or lead to nitrate and sodium sulfate. So we take equal volume of lead nitrate and sodium sulfate. That's the first point. Then we mix them together. Then it will form a precipitate. We will remove the precipitate of lead sulfate because it will produce lead sulfate by filtration. Then we will wash the precipitate or residue, you can also mention, and then we will dry the precipitate by the tissue paper, or you can mention a filter paper. So again, similar method to prepare the insoluble salt. We mix the two solutions, we filter to obtain the residue, we wash the residue by using a distilled water. You have to mention by using a distilled water. I just mentioned wash the precipitate, but it should be complete as with distilled water. And then dry the residue with a filter paper or tissue paper, or keep it in a warm place. You can also mention that. The next one, normally you will find this question is always a part in which you have to write the ionic equation for the precipitate. So what precipitate are formed here? The precipitate is lead sulfate, because lead sulfate is an insoluble salt. So as lead sulfate is an insoluble salt, the product is PbSO4. And here we have to include the state symbol. So what are the ions present here? If we want to prepare a lead sulfate, what are the ions present?
Pb plus 2 and SO4 minus 2.
Pb plus 2 and SO4 minus 2. And include the state symbol. So for ions, it is always aqueous. And for solid, the precipitate will always be solid. So this is the ionic equation. It's of 2 marks. 1 mark is for mentioning the ions in the product, and 1 mark is for the state symbols, correct? So ions are always aqueous and the precipitate is always a solid. In question 4, describe how you would prepare pure dry sample of copper 2 nitrate in the lab by reaction of nitric acid and copper 2 carbonate. So we have copper 2 carbonate, CoCO3. We mix with nitric acid, HNO3. As a result, it will produce, all nitrates are soluble. So if you are preparing an insoluble salt, they will mention. Otherwise, all the salts we will consider as soluble. If it is an insoluble salt, that will be mentioned in the question. And there's also a table I discussed in the beginning of the chapter, topic 12, which was about soluble and insoluble salts. So all nitrates are soluble. So it will produce copper 2 nitrate plus carbon dioxide plus water. And the equation must be balanced. So if I put 2 multiply by 3, 6, 9 oxygen and 9 oxygen. So it's already balanced now. So what we do, because we have copper carbonate and we are preparing a soluble salt. So here, as you can see, we are preparing so we add excess of copper carbonate until no more dissolve. Like this is copper carbonate, CuCO3. And this one is nitric acid, HNO3. But here in this example, HCl is written, but example, we are preparing copper nitrate, so it must be nitric acid. We add this copper nitrate until no more dissolve or no more bubbles. When there is no more bubbles, now it's not nitric acid. What it turned, the solution will turn into copper nitrate. But first thing what we have to do, we have to remove this extra copper carbonate, unreacted copper carbonate. So how we remove this unreacted copper carbonate? So which technique can be used to remove this unreacted
By
copper carbonate?
filtration.
So we'll do filtration, and then you'll mention the points of crystallization. So we'll add copper to carbonate or add excess of copper carbonate or copper 2 carbonate to nitric acid until no more solid dissolve, or the solid dissolve. Then we will remove the unreacted copper carbonate by filtration. And after removing by filtration, we have to use heat and concentrate the solution till the point of crystallization. Then we will cool down the solution. Then we'll filter to remove the crystals, and then we'll dry the crystals, but we cannot wash these crystals as this is the soluble salt crystals cannot be washed. So add excess of copper carbonate until no more bubbles form. The mark distribution, like when you mention add copper to carbonate until no more bubble form, that is 1 mark. You filter to remove unreacted copper carbonate, that is a 2nd mark. Then evaporate, like heat and concentrate the solution, 3rd mark. Until point of crystallization, 4th mark. And cool, filter and dry is actually the 5th mark. And 1 mark is for the equation as well. As they mentioned, include a chemical equation. So they mentioned that you have to write an equation for that. 1 mark is for the equation when copper carbonate is reacting with so CuCO3, and whenever the equation you write, it must be a balanced equation. So it will produce copper nitrate plus carbon dioxide plus water. And we just put 2 to balance oxygen, and rest all of them are balanced.